What if we told you that every glass bottle you toss in the recycling bin can come back as a new bottle in as little as 30 days? Or that recycling glass saves enough energy each year to power entire cities? From the shattered remains of bottles to the glowing furnaces that melt them into a brand new future, this is how 100 million tons of glass are recycled every year in factories across the world.
Glass is an incredible material. It's durable, versatile, and endlessly recyclable. But here's the thing. It doesn't decompose. A single glass bottle can sit in a landfill for up to 1,000,000 years. That's right, 1,000,000 years. Thankfully, we found a way to turn this environmental challenge into an opportunity through the marvels of glass recycling. The journey begins with collection. Around the world, glass is gathered through a variety of systems tailored to local infrastructure and habits. Many cities rely on curbside collection programs where residents separate their glass waste into specialized bins for easy pickup by waste management trucks. In other areas, centralized drop-off points allow people to bring their glass items to dedicated containers, often sorted by color. Some regions incentivize recycling through deposit refund systems, where returning bottles can earn small cash rewards or grocery discounts. In European countries, this is a routine practice, fostering widespread participation and higher recycling rates. Conversely, in some parts of the world, glass collection is carried out informally, often by marginalized groups who sell the gathered glass to recycling facilities. Once collected, the glass is transported to sorting centers or recycling plants. Trucks filled with glass bottles, jars, and other items deliver their cargo to facilities designed to handle large volumes of material. At the plant, the first step involves unloading the glass into holding containers, where it's prepared for the next stages. The process may seem straightforward, but it's far from simple. Sorting is a crucial step in glass recycling. Glass comes in 3 primary colors: clear, green, and amber, and each has specific uses in manufacturing. Mixing colors can compromise the quality of the final product, so sorting by color is essential. This task is handled by advanced optical sorting machines equipped with lasers and sensors. These machines analyze each piece of glass as it moves along a conveyor belt, identifying its color based on the light it reflects. Once identified, the machine uses air jets or mechanical systems to direct the glass into the appropriate category. These machines operate at remarkable speeds, sorting tens of thousands of glass fragments every minute with incredible accuracy. But sorting by color is only part of the equation. Contaminants like labels, caps, adhesives, and food residues are some of the biggest challenges in glass recycling. Removing them require multiple stages of cleaning. First, magnets extract ferrous metals, such as steel caps, while electromagnetic separators tackle non-ferrous metals like aluminum. These systems are powerful enough to remove even tiny fragments that might otherwise go unnoticed. Next, pneumatic systems blow away lightweight contaminants, including plastic and paper, using controlled air currents. For glass intended for food or beverage containers, wet cleaning processes ensure thorough removal of stubborn residues. These washing systems use water jets and mechanical scrubbers to eliminate adhesives, dirt, and organic matter, leaving the glass spotless. This meticulous process is essential for maintaining the quality and safety of recycled glass products. Once the glass is clean and sorted, the next step is crushing. The glass is fed into powerful crushing machines, which break it down into small, uniform pieces known as cullet. These machines come in various types: hammer mills, jaw crushers, and gyratory crushers, all designed to reduce the glass to a specific size. For instance, hammer mills pulverize the glass with rotating hammers, while jaw crushers use a stationary plate and a moving one to crush the material. After the initial crushing, the cullet is sifted using vibrating sieves. These machines separate the glass by size, ensuring a consistent particle size for the next stage. Oversized pieces are sent back through the crusher to minimize waste. Uniform cullet is easier to handle and melts at low temperatures, making it an essential part of the recycling process. Also, cullet melts at a lower temperature than raw materials, saving significant energy during the production process. Crushing is not just about reducing the size of the glass, it also makes the material easier to handle and prepares it for melting. Now comes to the melting stage, where the real transformation begins. The cullet is transported to industrial furnaces that operate at temperatures as high as 3,000 degrees Fahrenheit. Inside these furnaces, the cullet liquefies into molten glass, ready to be shaped into new products. One of the most significant benefits of recycling glass is its energy efficiency. Because cullet melts at a lower temperature than raw materials, it reduces energy consumption by up to 30%. Every ton of recycled glass saves more than a ton of natural resources, including sand, soda ash, and limestone. Many modern furnaces are powered by renewable energy sources like wind or solar, further minimizing the environmental impact. Massive electrodes inside the furnaces sustain the intense heat, while sophisticated systems regulate the temperature and prevent energy loss. Once liquefied, the molten glass is shaped into new products. The liquid is poured into molds to create items such as bottles, jars, and decorative objects. Factories rely on automated systems to ensure precision in shaping, with molds designed to meet exact specifications. But recycled glass isn't limited to traditional uses. In the construction industry, for example, it's used as an aggregate in concrete and asphalt, adding durability and aesthetic appeal. It's also transformed into fiberglass insulation, which helps improve energy efficiency in homes and buildings. Beyond that, recycled glass finds its way into art and design projects, becoming countertops, tiles, and decorative elements. After shaping, the glass is slowly cooled in a process called annealing. This step is very important because it prevents cracks and makes the glass strong and durable. Once the glass has cooled, it goes through quality checks. Machines with cameras and sensors inspect each piece for problems like cracks, bubbles, or uneven shapes. Any item that doesn't meet the standards is sent back to the start of the recycling process, making sure nothing is wasted. But the process does face some challenges. Contamination is a big problem, especially when materials like Pyrex, ceramics, or heat-resistant glass mix in. These materials melt differently and can disrupt the recycling process. To solve this, advanced sorting machines, including AI-powered technology, are being used to detect and remove these items more effectively. Transportation is another issue since glass is heavy and costly to move over long distances. Many recycling plants are now focusing on local operations to cut down on these costs and reduce emissions. New technology has been essential in solving challenges in glass recycling. AI and automation have made sorting and processing much more accurate. Some factories now use closed-loop systems, where recycled glass stays on site and is reused without leaving the facility. Lightweight glass designs are also becoming popular because they use less material and are easier to recycle. These innovations are making glass recycling more sustainable and cost-effective. The environmental benefits of recycling glass are huge. Every bottle recycled means less waste in landfills and fewer greenhouse gases released into the air. Unlike many other materials, glass can be recycled endlessly without losing its quality. This makes it one of the most sustainable materials that we have. Recycling also saves natural resources, like sand and limestone, and uses much less energy than making new glass from scratch. Together, these benefits show how important glass recycling is for protecting the planet and fighting environmental problems. The uses for recycled glass go way beyond making new bottles and jars. In construction, crushed glass is used in roads and building foundations because it's strong and eco-friendly. In farming, tiny glass particles are used to improve soil by helping it hold water and stay healthy. Artists and designers also love recycled glass for making countertops, tiles, and other creative pieces. It's a great example of how recycling can lead to innovative and useful ideas. Looking ahead, the future of glass recycling is exciting. Governments and organizations are working on better ways to collect and recycle glass while encouraging more people to participate. Scientists are developing systems where glass can be recycled endlessly without any waste. New technologies, like AI sorting machines and furnaces powered by renewable energy, are making recycling faster and better for the environment. With these improvements, glass recycling is set to become a big part of creating a greener and more sustainable world. And that's how over 100 million tons of glass are recycled every year, from the initial collection to the advanced sorting and melting that turns waste into valuable new products. But before we go, we want to know, what's your favorite recycled glass product? Let us know in the comments below. If you enjoyed this video, don't forget to hit subscribe so you won't miss out on more behind the scenes looks at fascinating factory processes.